Okay. So today we continue with Super Goal 3.3, applying the distributive property. We have used the distributive property before. Okay, we have not used it with powers though, which is what you're going to see now. And we have not used it other than multiplying a monomial by a polynomial. That's the only way we've used distributive property so far. So we're going to change that up. Okay. So distributive property, monomial times a polynomial. So these first 5 examples are that. A monomial term meaning a single term, no addition or subtraction in the midst of it, and then times a group or quantity of 2 or more terms. That's a polynomial. So all of these are monomials on the outside, and then inside we have polynomials. So a simple distributive property, applying, however, the rules of exponents. Okay? So, not too difficult. So, we start x times x, and you don't have to draw all those little arcs and arrows. X times positive 3, positive 3x. And you're done. There's nothing else to do. Those terms are not alike, so they cannot be combined together. Four x squared times 5x squared, 20x to the 4th power. Add the exponents when you are multiplying. 4x squared times negative 2xy, negative 8x to the 3rd, and my y just comes over. It has nothing to be combined with. That 2xy is one term, so you're not distributing 4x squared to the 2, and then the x, and then the y, all together, one term. 4x squared times positive y squared is a positive 4x squared y squared. Again, when we're multiplying, remember that you are adding your powers. Watch your signs here. Negative AB, understood 1, negative 1 AB times positive 2a squared b is negative 2 a to the 3rd power, b to the 2nd power. Again, adding my exponents. Understood 1 plus 2, so there's my 3 on the a, and 1 plus 1 is 2 on b. Negative ab times positive ab squared, negative, positive times a negative, a to the 1 plus 1 is 2, b to the 1 plus 2 is 3. Not like terms, so that is as far as I can go. One-fourth x squared y. Some of these questions, you'll notice that my exponents, I have to go in after I do it and do a special thing to make them smaller, and I forgot to do it on this one, so it looks weird. 1/4 x squared y times 16x squared y. Remember that when we take an integer, 16, times a fraction whose numerator is 1, 1/4, it's like 16 divided by 4. Okay? So 1/4 times 16 is positive 4, and then x to the 4th power y. And 1/4 x squared y times 8xy squared is like 8 divided by 4, so positive 2x to the 3rd power, 2 plus 1, and y to the 3rd, 1 plus 2. And again, those are not alike. I can go no further. Cannot add terms that don't have the same variable component to it. And then my last one with monomials. I'm going to work from the inside out because I have multiple grouping symbols. So I'm going to have x come down or over, 2x come over, and here's where I'm distributing. So negative 3 times 1, negative 3 times negative x, positive 3x. So I've gotten rid of my parentheses. When you distribute, the parentheses are gone. You have a choice here. I like the choice of adding like terms together first, so I'm going to do that. Because I can. So 2 and 3, 5x. minus 3. And now I'll get rid of my bracket by distributing. X times 5x, 5x to the second power, x times negative 3, negative 3x. Cannot combine any further because those terms are not alike. Okay, anything that we want to look at in those first 5? I can go back and reiterate. Okay, we're going to continue with distributive property in a different form. We're going to be multiplying specifically binomials times binomials. A 2-term polynomial times a 2-term polynomial. Okay? And I'm going to use the FOIL method. Has anybody not heard of that? Okay, so FOIL is an acronym that stands for first, outer, inner, last. First times first, outer times outer, inner times inner, last times last. It really is not important for goal 3. It's really not important because all you're doing is applying the distributive property twice. It's really what you're doing. I'm going to make sure you see that, okay? However, the concept of FOIL is hugely, hugely important for how I teach factoring in goal 4. So while I don't really care if you apply FOIL or not, you're going to see me do it, okay? But it's not really necessary at all. But the concept is important for the next one, okay? Keeping in mind that you can only use it when you have 2 terms times 2 terms, okay? So these would be considered my first terms, the x and the x. These are my last terms, the 7 and the 3. The outer terms are the ones on the outsides of the parentheses, and the insides, inners, are the ones on the insides of the parentheses. But here's the real question. Why does outer only have 1 t but inner have 2 n's? Who's going to answer that one for me? You're like, well, I don't know. So I asked your English teacher because I don't know. I want to know. Stumped you, didn't I? Just when you thought math was easy. Now I've got you all in a tizzy about those letters. Okay, so you got to know when you can use FOIL. I can use it only when I have 2 and 2. So I'm going to draw all these little lines, and then I don't typically do that once we get through this though. So first times first, x times x is x squared. Outer times outer, positive x times positive 3, watch your signs, positive 3x. Inner times inner, positive 7 times positive x, positive 7x. And last times last, positive 7 times positive 3, positive 21. Many times, many times, but not always, the outer term and inner term products are like terms. Many times the outer product and inner product are like terms, which means I can combine them. In fact, it's my guess that some of you would not even have written this first line. That you may have done that outer and inner together in your head and combined it. Okay, which is an important concept for goal 4. I'm not going to do that right now, but if you see that and recognize that and can do that, that's fine. Now, what did I do? I took x times x, and then I took x times 3. So all I did was first, if I could cover that up, I distributed x to the second parentheses. Then I distributed positive 7 to the second parentheses. So I just used the distributive property twice, is all I did. Okay, 2 terms times 2 terms. 3x times 2x, 6x to the second. Outer times outer, 3x times positive 1, watch your signs, positive 3x. Negative 5 times 2x, minus 10x. And last times last, negative 5 times positive 1 is negative 5. The middle terms are alike. They're not always the middle terms, but if you FOIL, often they are. So when I combine positive 3 minus 10, I get negative 7x. Two terms, FOIL. First times first. X squared times 7x. 7x to the third power. X squared times negative 5, negative 5x squared. Inner times inner, negative 8 times positive 7x, negative 56x. And last times last, negative 8 times negative 5, positive 40. All terms are different. X to the third, x to the second, x to the first, constant term. They're all different, which means I can go no further. That is my final answer. Okay, in this next one, FOIL, 2 times 2, or 2 terms, 2 terms. First times first, 5y times 5y, 25y to the second. Outer times outer, positive 20xy, 5y times 4x. Inner times inner, negative 20xy. Should you write one of those terms as xy and the other one as yx, they're still the same. A, B, and BA, same thing. So the order of the variables wouldn't matter. I usually write them alphabetical. Last times last, negative 4x times positive 4x is a negative 16x squared. The middle two terms are alike. I have a positive 20 and a negative 20, which cancel each other out. So those are gone. And I end up with just 25y squared minus 16x squared. Now, this is kind of what I would call a special problem, because when you FOILed, you had terms completely cancel each other out. And you'll notice what it looks like. My first terms are the same. My last terms are the same, but opposite signs. Okay? So they look almost alike. There's a special name for this, and we're going to use it actually fairly often. These are called conjugates. That's a G. Conjugates, C-O-N-J-U-G-A-T-E-S. Those are called conjugates of each other. And anytime you multiply conjugates, whether it's something like this, or whether you start involving radicals, if I took 3x plus the square root of 2 and 3x minus the square root of 2, or I took imaginary numbers, which I'm going to work with next semester, and I took 5 plus 2i times 5 minus 2i. Anytime you multiply conjugates, if you FOIL, F-O-I-L, the outers and inners are going to cancel each other out. And that's a really important concept with square roots and imaginary numbers that we're going to work with this year. So conjugates are a really important concept. So if you recognize that you have two binomials and they're conjugates of each other, you don't really have to FOIL the whole thing, because you already know that the outer and inner are going to cancel each other out. So you can just first and last. You don't have to do the whole thing. Okay? If you recognize that. If you don't, then you can just keep going and cancel them out and whatever. Okay? But important concept is something we'll be doing a few different times this year, conjugates.